Okay, now this question is really just trying to see if you have an understanding of procedures in doing experiments and why certain things are done in experiments to ensure either maximum yield or to prevent um, speeding up the reaction, things like that. So anyway, the answers for this are actually very self-explanatory. So instead of talking through it, I thought I'd show the answers and just talk to them a little bit. Now, and looking at the answers, one of the things you were asked to look at was, the reason there's a dry flask. And if you look at the reaction between a carboxylic acid and an alcohol, obviously it produces an ester and water. Now, normally we tend to ignore water in equilibriums, unless they're homogeneous equilibriums, in which case, if they're all liquids, you include it. Most of the ones that you tend to look at in school tend to be heterogeneous ones. Now, in this case, water is actually a product. So if you increase the amount of water, that tends to shift the equilibrium to the left. So in this case, that's one of the reasons that we would make sure it's dry. The concentrated sulfuric acid, you should know by now that it does remove the water. It's a dehydrating agent, which speeds up the makes more product form really, and it also acts as a catalyst. So the actual rate of equilibrium where it's achieved is increased as well. So those first two, the dry flask one, I would actually expect that most students wouldn't be aware of, but the concentrated sulfuric acid one you should be. Now, reflux is a way of speeding up a reaction. We have the condenser in place so that the volatile gases or that form, which can either be from reactants or products, depending on the experiment, will condense back to a gas from a liquid because it's cooled, and you can ensure that you get a maximum rate of reaction without losing products. And the ester, because it's got the lower boiling point, will be the one most likely to be lost. But at the same time, we also need to be concerned about distilling off the ester, and that's where the boiling point's kind of important, because it's a lower boiling point than the acid or the alcohol. It's the first one that will actually come across. So all this is to ensure maximum yield. Typically in organic chemistry we don't get very high yields, so a lot of the things we do are to ensure we get as much as possible. Now obviously we've got the organic acid there, and one way to try and improve purity is to add something that's going to neutralize it, and that would be the carbonate. When that stops bubbling, that would mean that the acid had been neutralized. And we need some anhydrous agent that can be helpful to remove any water that does form in the reaction, and calcium chloride, and there's a couple of different ones that can be used. And that's what that's used for, to try and remove any water. We want the organic product, and so we want to have nothing else there if we can avoid it. So that's that question, and it's just a matter of going into reasonable detail on that.